All right, here we go. Our objective for today, I can simplify exponential expressions using multiplication properties of exponents. Read together. One, two, three. I can simplify exponential expressions using multiplication properties of exponents. So what do you guys notice? That we're still on the same concept, yes? And everyone, what is our concept? What is our concept for today again? Exponential expressions, right? We haven't moved on because we still need to finish up with that. All right, so in your Freire model, what goes in the center? Exponential expressions. So by now, I shouldn't have to go over the definition anymore because yesterday I repeated it like 1,000 times without looking at your notes. Tell you never the definition for exponential expressions. Okay, let's see if you did something like this. Who said exponential expressions? A numerical variable expression raised to a power greater than 1. Something close there, anyone? Yes? Or somebody should have said numerical or variable expressions raised to a power? Yeah? Very good. And of course, you're going to do that by yourself at home. Fill that in by yourself. Look up to the screen. Don't copy these steps. You already have them. Yes? So yesterday we started off by identifying the three properties, product of power, 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 products, but yesterday we only did the first. Today we're going to cover the last two, power of power and power of products. That's why we don't need the steps. You already have them, yes? All right, so watch. Reminder, I saw some of you are forgetting to write the exponent of 1 on those like numbers or variables that don't have an exponent. Make sure you keep writing it, please, because when we get to other properties, if you don't write the 1, you're going to start making small mistakes. Okay? Do you understand already the commutative and property, commutative and associative property, how they work? Yes, and why are they called what they're called? Yes, we covered that yesterday. Once again, we covered the product of powers property, and we saw that for home plate, we saw some of these. Aren't these a piece of cake now? Yes? Yes? Yes, right? Yes? So far, so good? And that brings us to, before I go into the property, I want to revisit for some of you scientific notation. So writing utensils down, pay attention. Here it goes. So scientific notation, the reason I'm going to go over this, there's going to be one problem tonight in your home plate that uses scientific notation. But I'm going to clarify for those of you that haven't seen this, those of you that already saw this, to clarify and remind you of the parts. And here you go. Pay attention, please. So scientific notation, what does it look like? 2.3698 and 10 to the 7. So watch. Let me just go over, this is what I call the anatomy of what I'm trying to show you. The anatomy of scientific notation has two things. It has, well, three things. It has a decimal. You guys see a decimal number here? Yes. It has a base 10 with an exponent here, and it has a multiplication in between. Does everybody see that? Okay, this is what we call scientific notation. So what is so important about this? That you can only have one digit on the left of the decimal, and it cannot be 0. So it has to be from what number to what number? From 1 all the way to what? 9. That's as much as you can have. The rest to the right, it doesn't matter how many numbers or digits you have on the right of the decimal, but on the left you can only have 1. The second thing that I want you to notice is that there's a multiplication sign. Okay, so it's multiplying. What is it multiplying? It's multiplying something that we call times base 10. Base 10. And why base 10? Because every position of a number has how many different digits? 10, from 0 all the way through 9. But in scientific notation, the only one that can only have from 1 through 9 is the digit to the left of the decimal. Is everybody following so far? All right, so now watch. Why is this so important? Because scientists and scientific in the scientific world and mathematics, they use scientific notation to write big numbers in a little bit smaller way and to compute different amounts. Is everybody paying attention? Here we go. So example Q. If I was to give you the number 57143, I'm going to write this in scientific notation, so pay attention. This number, even though it does not have a decimal, we can picture a decimal in there. It does have one, but it's invisible. Can you guys see it? You guys see it? No, you can't because it's invisible. No, you can't. Yeah, but can you see it? Oh my goodness, you can picture it in your mind, but can you see it? Alright, so watch. Any number that does not have a decimal, we can picture it. Now you're going to see it because I'm going to place it where it goes. It's always to the far right. Now you can see it. Everybody there? So now check this out. I'm going to make this number look like this one. So where shall the decimal go? So I need to move this once, twice, 3 times, and 4 times. So my new number is 5.7143. So is it kind of looking like this now? What am I missing? The multiplication sign, the base 10, but now I need an exponent. Well, what exponent do I place? Let's see. How many times did I move this? 1, 2, 3, 4. Well, guess what goes here? 4. That's how you change a number to scientific notation. Let me give you another one. Example super Q. I'm going to give you the number 238. Don't say it out loud. Can you picture the decimal on there? Okay, now you're going to move it. Make it look something like our scientific notation. Now you have a scientific number now, yes? Tell your neighbor that new scientific notation, please. So let's see. You picture the decimal here, you moved it twice, that means your new number is 2.38, and you said times 10 to the second power. Hands if you got that. Okay, copy that please. Copy it on the Q side of your notes. Go. Copy that. Go. Once you're done with those, I want you to do this next one by yourself. Example mega Q. Change this number to scientific notation. 1, 2, 3, 4, 5, 6, 7, 8. Change that one to scientific notation by yourself. Go. And so if you're done with example mega Q, okay, 10 seconds. All right, tell your neighbor the new scientific notation for example mega Q. All right, so I heard 1.2345678 times 10 to the what? 7th power. We get this, yes? Okay, last example before I move on. Look up, please. Example Michael Jordan Q. Okay, writing utensils down. Pay attention to this one. 0.0000235. All right. Now look at all these first. Let me go over these really quick. We move the decimal to the left. We put that there. Move this decimal to the left. We put that there. Move the invisible decimal to the left, and we put this there. So now look at this one. 1, 2, 3, 4, 5, 6. So now we have 2.35 times 10. Tell you never the power that goes there. That is correct. -6. So anytime we go to the left, they say what? Positive. And anytime we go to the left, to the right, we put a negative. Copy that one, please. Okay. So, why is this so important? Well, let me show you a word problem where we use scientific notation. Look up to the screen. Look at this one. It says, example, light from the sun travels at about 1.86 times 10 to the 5th miles per second. Miles per what? That means in 1 second, let's count 1. That's how fast it travels light into distances. So from the sun, it travels 1.86 times 10 to the 5th in 1 second. But they want us to find, because it says it takes about 15,000 seconds for light to reach Neptune. Find the approximate distance from Sun to Neptune. Write your answer scientific notation. So watch. Example 3Q. Check this out. So how much is it in 1 second? 1.86. Sorry, 86 times 10.5. I mean 10 to the 5th. Let me write this. 1.86 times 10 to the 5th. But this is only in 1 second. How many seconds are going to trespass here? 15,000. So what do I need to do? Times 15,000. Because we want to find out that distance, yes? So question, can we rewrite this number in scientific notation? Do it in your noodle. Okay, who's got that number? Luca, go.
1.5 times 10 to the 6.
Hands, have you got that? That is correct. So first thing, we need to change it to scientific. So we get 1.86 times 10 to the 5th times this. So now, question, do we have multiplication all the way through? Let's see, multiplication, multiplication, multiplication. Do we have multiplication all the way through? So now, what's going to allow us to move things around? What property? Commutative property. So it's 1.86. I'm going to bring this one over here, times 1.5 times 10 to the 5th times 10 to the 4th. Does this look familiar? Yes. What does this become? 10 to the 9 times. These are not the same base, but what do we do with these two numbers? Multiply them. 1.86 times 1.5, that's 0. I got 3. 43, I got 4. 5 plus 4, that's 9. And then this 1, 6, 8, 1, that's 0, 8, 17, 2. How many decimal places? Yeah, I did that on purpose here for paying attention. How many decimal places? 3. So this is 2.790. Question, is this scientific notation? Yes. So therefore, what is the distance from the sun to Neptune? 2.790 times 10 to the 9 miles away. Copy that, please. Miles. This one you can copy underneath your prayer model. Miles. Don't copy the word problem, just copy from here down. Copy that. There it goes. Look up. So product of powers is what we covered yesterday. Let's see if this generalizes the idea. If two exponential expressions have the same base, what do we do to the exponents? We add. Do you agree with this so far? Okay, so let me use numbers. So if I had 3 to the second times 3 to the 0, are they the same base? Yes. So that what would we do to the exponents? 2 plus 0. So this is 3 to the second. So far so good, yes? So now watch. What is 3 to the second? What is this? What is that? Okay, so therefore, question. 9 times what gives me 9? Everyone.
1.
Okay, so question. What is 3 to the 0? Well, you just said 1. Let's see. What is 9 times? 9 times what gives me 9? And you're saying that this is 0. Could this be 0? No, because then it would be 9 times 0 is 0. But is this 0? So what are we saying? That 3 to the 0 is what? 1. And it works with all kinds of numbers. So how can I generalize this idea for all the rest? Talk it over your neighbors. How can I generalize this idea? Let's see. Help us out, Reagan, on this one. How can we generalize this idea? We change this 0 to a 1. Close. Devin, how can we generalize this idea? Does that make sense? Any number to the 0 exponent is, but not only numbers, it works with variables. So anything, let's just say for right now, anything to the 0 exponent is 1. So if I was to say Nanel to the 0 exponent, what does that give us? 1. How about Isaac to the 0 exponent? 1. Everybody understand so far? Let me continue. Look up. Look at this one. I got 3 to the second times 3 to the first is 3 to the second plus 1, which is 3 to the third. So this is 27, this is 27, this is 9. Question, 9 times what gives me 27? 3. So now watch. 3 to the first is 3. How can we generalize this idea? Tell your neighbor, please. All right. So how can we generalize this idea itself? Any number to the exponent of 1 equals itself. But since we can use it with variables, it's anything to the exponent of 1 is itself. Does that make sense? So if I was to say Julian to the first power, what does that give us? Luca to the first power. Luca, it's itself. Everybody get the idea? All right. So turn your paper over and write this property down. Power of powers property. Oh, yeah. Power of powers property. Example Q. Power of powers property. And once again, for this one, I'm going to show you. I'm going to be quiet. I'm going to have you do the thinking, do the reading part. I'll let you guys talk it over, and then we're going to come up with a definition. Okay? Okay, writing utensils down. Look up to the screen. Pay attention, please, pretty please, with a cherry on top. Look up. Talk to your neighbor, see what's going on there. Okay, you got 1 minute, copy that please, and then we'll go over our definition. Underneath that, make sure you write a little asterisk and a heart. Aww. And then we'll start with our definition. Copy that. All right. All right, so let's see. So now that you talked it over, now we have an idea of what's going on. We need to come up with a definition. We can get us started. Go ahead, Devin. Get us started, please. Okay, that's the rule. How do we start our definition, a formal definition? Thank you. The power of powers property. Julian? Is when, hold on. Is when you, okay, before we say take and make it too wordy, look up to the screen. Whenever this is happening, this is what we call rising or raising. Raise. So, with that said, Julian, the power of the powers property is when you raise, close, raise, and, not a, hold on. What are these called? All of these together, Julian. No, all of them together. All of these inside of the parentheses, they have a specific name. Yes, Hunter? Exponential expression. And start low. The power of powers property is when you raise an exponential expression. When you raise it to what? To, what are we raising it to? Yes? It's not a variable. This is to an exponent. And just put another exponent to another exponent. Okay, so raise an exponential expression to another exponent, comma. What do we do, everyone? What's the rule? Devin? You multiply the exponents. 10q. Pretty simple? Yeah, right? Example, mega q, do this one by yourself. Parentheses, 3 to the 5th. And raise that to the 100th power. 10 seconds. 9, 8, 7, 6, 5, 4, 3, 2, 1. Got it? Tell your neighbor what you got. Very good. 3 to the 500. All right, so now why does it work? Look up to the screen. Check this out. 2 to the 3rd, it says we do it how many times? 4. 2 to the 3rd, 2 to the 3rd, 2 to the 3rd. This is what we call factored form. Now look, can we use yesterday's property, product of powers? Are they the same base? Yes. What happens to the exponents? Add 3 plus 3 plus 3 plus 3. From now on, whenever you have doubts in regards to what you're getting at the end, factor it. Or, as I tell my students, when in doubt, factor out. You got it? Last property. You're saying that was it? Yeah, that was it. Copy power products property. Example, Shazam Q. Power products property. And copy this one, parentheses, 2 to the 5th, x to the 7th, y to the 8th, and all that to the 3rd power. And we're going to do this one together because your noodle is already there. Look up. And start with this one. 2 to the what, everyone? 15. And then we got this one, x to the what? 21. And then this one is y to the 24. So you guys already know this property? And this was what? 21. Okay. So watch. What's the difference between this one and this one? This one and this one. Yes? Yeah. More factors on this one. But it's the same rule, isn't it? All right. So by yourself at home, I want you to come up with a definition for power product since it's very similar to the power of powers. Yes? All right. Home play for tonight is play sheet 7.3 is over here. Pick up one on your way out. Home play sheet 7.3C. Good one, guys. Enjoy your home play. See you guys tomorrow. Bye.